Either me or Shibalia will read out the questions from the chat box.
Fantastic.
Okay.
Okay, so shall we get started?
Yeah.
Can you hear me?
Good evening to all our viewers. On behalf of the IEEE, yes, I can hear you, sir.
Okay.
Give a short intro. On behalf of the IEEE Computer Society Kerala chapter, I welcome you all to the third and final webinar of our Artificial Intelligence webinar series. I'm honored to welcome our speaker for today, Mr. Brijes Madhavan. He completed his studies from Indian Institute of Management, Kolkata, and further he went on to become a research associate at International Institute for Sustainable Future and a postdoctoral fellow at the Indian Institute of Science. He worked at Hewlett Packard for 6 years and is an expert in the fields of big data analytics, data science, and artificial intelligence. He is currently the CEO of Curvelogics Private Limited in Bangalore. Once again, we are honored to have you with us today, sir. And without further ado, I invite you to share your thoughts with us.
Thank you, Anne. Thank you very much. Thanks to IEEE and the team conducting this event. Right, it's an honor to be here. And so, primarily, let me start with my introduction. Anne has already briefed you all about the academic background and so on. So basically, like Anne said, I have a PhD in mathematical ecology. I went on to do my postdoctoral research at IISc. I also went on to take a management degree in IIM Calcutta, right? And worked with organizations like HP, Ernst & Young. Here in Trivandrum, there is an innovation hub, one of the best of the innovation hub of Ernst & Young. Right, I set up the artificial intelligence and advanced analytics team within that organization called the Innovation Hub. Right, and from then on, I moved on to start my company called Curvelogics. Right, and it's headquartered in Bangalore, but the primary operations is based out of Trivandrum. Right, I moved out of Bangalore for health reasons. Right, and now primarily we work out of Trivandrum. Right, and what is special about this company, because I have a research background, right, and I've also spent significant amount of time in statistical modeling and simulation and all of those kind of things, right, something that brings that two together, right, is what we focus on. So we primarily focus on AI, and we help SMBs and large MNCs to accelerate, to take techniques, methods, etc., that are more of a R&D grade, something that is just invented maybe like last year or so, right? And we take those kind of innovative inventions to production, right? So although theoretically there could be things that are possible in a laboratory setup, you could have achieved certain things, but taking it to a production grade where it can touch millions of people's life, right? And that's a difficult task, right? So we help in that. So because I have spent significant amount of time in the corporate and the academia, this kind of interests me a lot, right? And within AI, one of the fields that heavily interests me is the generative side of AI, right? So if you're looking at if you look at the first of the neural networks, right? It started way back in the 1940s, right? Somewhere around 1956 is when people went on to really implement that in a machine, right? And as usual, as part of certain defense projects, right? From then on, right, we've only seen machines being passive. You tell the machine certain input, tell the machine certain output, it will figure out the pattern underlying it, and then you could use it for predictive modeling and so on, right? But things have changed in the last few years, right? Specifically in the last, somewhere after 2014, for example, right? Things have changed tremendously, that machines have gone on to being passive to generative, right? They create, it could be content, it could be design, it could be strategies, etc. Right? So I'll be primarily talking about that today, right? And Curvelogics has multiple sister organizations. We are also into computational genomics. So before I start, right, and would it be possible for the audience to actually give the response on chat or so? I'm not able to see that screen here, but I would just want to take a quick feedback. Anybody understands what this picture is all about? If anybody can guess what this picture is all about.
So they won't be able to respond because we are streaming it on YouTube.
Okay.
So
So it doesn't matter. So we will go ahead, right? So,
yeah.
so typically when I give lectures in Kerala, people end up saying, typically people who are interested in cooking actually give me a response saying that this looks like a cooking contraption that, creates noodle kind of output when you put the dough in, right? It's called, in Malayalam, it's called nulputta, right? And so they think that is a cooking contraption, and the guys or people who are into into automotive bikes and all of them, they end up saying this is a spark plug, right? It is neither of it, right? This is something called an evolved antenna, right? And this was something that was created way back in 1997, right? So even before that, right? A bunch of scientists from NASA went on to create antenna. Only thing is that they didn't manually create it. They created an algorithm that actually could come up with a design of an antenna, right? So this is an antenna that was actually designed by AI engine, right? And the algorithm behind that was a genetic algorithm, right? So genetic algorithm is something that is heavily inspired by natural selection and principles that were outlined by Darwin, right? Evolutionary theory, right? So here it is about how DNAs or how genes will mix and evolve to survive better. All of those that are not high performers would be left out and so on, right? So natural selection is what it's called, right? That theory goes into it, right? And it is the rules in that algorithms are very simple, but the output is phenomenally good, right? And it's pretty fast compared to certain brute force based algorithms, right? So and this is known to the computer science community, the machine learning community for a while, right? But suddenly, right, this has we've started seeing the utility of these kind of algorithms more and more in the last few years. Companies like Autodesk, right, who make CAD related software, have built features in their software like AutoCAD and so on, where you just have to tell the objectives. You just need to say, hey, I want a design of a particular kind, right? And this is the kind of material that we're using, right? And so on, and it would end up creating designs like this, right? And one of the key things that goes into it is called topology optimization, right? We will look at some of those designs that is unbelievable, right? Humanly, it is even not possible to generate, is what the scientists say, right? And from the mouths of the authors, Hornby et al., right, who are from NASA, right? What is that they're talking about? Let's say, so in the 1997, when they published this paper, this is the abstract of the paper, right? Whereas the current practice of designing antennas by hand, right, manually creating something is what they meant, is severely limited because it is both time consuming and labor intensive and requires a significant amount of domain knowledge. Someone who has serious expertise in antenna design only could have done that, right? Only could have build antennas that are super efficient, right? Where the weight is less, it can transmit and receive very, very efficiently, right? Even with a very small form factor, right? And but then the design that is here could not even have been created manually, is what they're saying. So someone sitting with a computer and designing, and then doing all the very complicated math to figure out what would be how efficient the antennas would be, right? Even with some of the best of the people there, antenna like this cannot be created, is what they say. And so, whereas the current practice of designing antennas by hand is severely limited because it is both time consuming, it takes a lot of time, right, and labor intensive, and requires significant amount of domain knowledge, right? Evolutionary algorithms can be used to, so the particular algorithm that I was talking about, genetic algorithm, is a subset of evolutionary algorithm, right? In this particular case, genetic algorithm is what was used, right? And the broader category that they're talking about, right, evolutionary algorithm, can be used to search the design space. So it generates many, many, many designs. The machine actually generates many, many designs, and the best of it, the most optimal, the most efficient of them are automatically selected, right? So it generates a lot of novel antenna designs, and the most effective ones are selected. Here we present an automated antenna design and optimization method based on evolutionary algorithm. Right? We have evolved efficient antennas for a variety of aerospace application, and here we describe one of the proof of concepts. Right? So this actually went into one of the spacecrafts, right, where this particular antenna was fitted. Right? So it was actually used, I think, somewhere around 2006 or so. Right? So in one of the I'm not sure if it's a Mars mission or so, right? One of the space missions, this antenna was part of those spacecrafts, and so this is just an introduction of what could generative AI be, right? So we're talking about an AI engine that can design, complicated objects like aerial here, right? And now, so the rest of what we'll be talking today is going to be, so I'll be touching upon things that are to do with generative design. We just talked about it, but what is the state right now, right? What is the state of the art right now, right? And we're going to be talking about algorithms which are called generative adversarial network, right? And which was invented somewhere in 2014, right? And certain outcomes of that, right? So generative design, generative adversarial network is one of those algorithms that is considered to be the most phenomenal AI-related invention in this current decade, right? In the current decade, this is considered the most phenomenal invention. So we will also be talking about how algorithms have, so that there are algorithms that are on the reinforcement learning side, etc., right, where it is not just about learning from patterns from the past, right, but on the go there are strategies that are evolved, right? And so we'll be just talking about some of those examples, and it is not just in engineering. It's not just in it's not just testing it. Testing AI engines' abilities to strategize by maybe playing games with the world's best champions or so, right? But it has seen its application, right, in everything from generating music, generating video, mimicking styles of artists, etc. Right? And so I'll be just touching upon that, and we'll also be talking about algorithms that write software programs, right? And algorithms that generate neural networks, right? So there are Google and other companies have ended up creating algorithms that create algorithms, right? And And what are we likely to see in the future is something that we're going to talk about. I will wrap up with the kind of thing that we do here at Curvelogics, um, uh, which we think is going to be a commonplace thing in the future, right? So let me start with a few examples. All of my slide deck that I'm sharing right now is filled with examples, right? So real application is what we're talking about, right? Where people have created, right? We're not talking about theory alone. People have converted that theory into practical applications. They have put it to use, and that those outcomes have been very effective, right? We'll start with same NASA that went on to create the evolved antenna, right? And um, so what you see here, um, what you see here on the right-hand upper corner is one of those NASA scientists working on a chassis of a interplanetary lander, right? Only thing is, when they started off this project, they wanted to use generative design to cut down the weight of this lander by 10%, right? A 10% saving of this lander means you could load more and more sensors into it. You could do more exploration, right? Because it's really expensive in terms of fuel, in terms of the distance that a rocket could effectively survive and reach, let's say Mars, for example, right? It would be pretty complicated, right? So even saving a kilogram, right, could matter a lot, right? So they were trying to cut down on the weight of this um, interplanetary lander by 10%, right? But while they were working with this company Autodesk, you all know what Autodesk is into. It is into creating CAD software, right? Um, Autodesk, along with NASA, went on to create designs of the chassis like this, right? And it went on to cut the cut the weight by a significantly large amount, right? Like 35% lighter is what it went on to create this design, right? So, but then if you look at it, it's so complicated, right? The designs are so complicated that it kind of mimics structures that you see in real world, right? Like if you look at the skeletons of organisms, or within the bone, the structures that are there, right? They all look like this, right? So the bones are porous and so on, right? So you see things that are material that is being used only where it is required, right? And the designs are also very, very sturdy, right? This in terms of strength, right? They are very, very phenomenally good, right? So NASA, from the antenna design, they moved on to creating the chassis designs and so on, right? And this is the final moon lander that they created, and again, AI generated that, right? And and now this has become like a common thing now, right? From artistic designs to, for example, lampposts and wheels and steering wheels and furnitures and all sorts of things, right? These software, the generative design softwares, have been able to create, right? And some of what we see here is manually created structures, right? This whole portion, right, compared to what was generated by a AI, right? And when manually created structure has many pieces there with nuts and bolts and screws and all of them, putting them together, the AI generated design is one monolithic piece, right? Very, very sturdy, very, very lightweight, right? And this particular object that was created weighed around 165 kilograms when it was manually created, right? A generative design AI went on to create an equivalent of that with the same strength, actually more stronger structure, right? And it weighed only 56 kgs, from 165 kgs to 65 kgs. So that's the big difference, right? So we're talking about less material being used, stronger structures, right? So now this has become such a common thing now that if today, this is a screenshot that I took today, 29th September 2020, right? And what did I search for? I searched for a drone chassis generative design, right? And you see all of those things that are phenomenally complicated, right? And many of them are designed um, uh, using generative design software, right? And so the point I'm trying to show you is that it has become such a common thing, right? That people are all using it for practical purposes, right? And complicated structures like drone, right? You need the important thing about drone is that it needs to be light, right? The drone's chassis needs to be light, but lightness means lack of strength, probably. Right now, it's a combination of strength and lightness, right? And let me quickly show you a screenshot of So this is something that Autodesk folks had created. What did they do? They went on to define what a drone chassis should be like, right? And the machine actually came back with a design like this, right? And you can see stark similarity between the drone chassis and uh, the 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 pelvic bone of a flying squirrel, right? Flying squirrels don't fly; they glide, right? They glide from extremely tall trees, and some of the flying squirrels that we see here in Kerala are larger than cats. They're fairly large organisms, right? It can be anything upwards of a half a meter, right? And they're very heavy organisms. No, not very heavy organisms. They're large organisms, but they're pretty light, right? And the lightness is ensured by having very complicated, skeletal structure, very similar to the birds, right? A lot of it is hollow, but the structure is pretty strong, right? And so the point here is things that took millions of years to evolve, like the pelvis bone of a squirrel, was quickly generated by generative design AI, right? So this particular AI went on to come up with a structure that is very, very similar in utility, like that of the flying squirrel. The drones are supposed to be flying, right? And if it falls down, it should not break, right? But it should be light enough that it can fly higher, right? All of these are the properties, right? And given that, right, the machine has come up with a design, right, and starkly similar to what you see in real world, right? In real world, as in like real organisms that has evolved over millions of years, right? So this is a great example of how softwares are getting smarter, how it is coming up with optimal structures, designs, etc. Right, and from then on, right, we have seen so many companies working on, coming up with fantastic drone chassis. And what is the problem here right now we are having with drone chassis here? The battery lives are so typically it is drones run on lithium ion batteries, right? And the time that a drone can fly is limited by the battery's capacity, right? Many times some of the best of the drones can only fly for 15 to 30 minutes, right? Because or you need to have bulkier and bulkier batteries, right? So as the battery technology evolves, gets better, drones can fly longer. But as of now, this is what it is limited with, right? Many of them can just fly 15 to 20 minutes, right? If it's using lithium-ion batteries. Okay. So and what is the alternative? Make the drone chassis lighter, right? Use composite materials plastics, right? Use structures in the drone that makes it strong yet light, right? And for that, AI softwares, or software with generative design AI capabilities have been very, very effective, right? Um, so those were more about the generative design, right? But then when we're talking about AI of today, there is a whole class of algorithm, right? A big category of algorithm that is called generative adversarial network, right? So if I just pick up a page in the Wikipedia, searching for generative adversarial network, you will see that generative adversarial network is a class of machine learning framework designed by Ian Goodfellow, right? In 2014, like I mentioned sometime back, it was invented in 2014, right? And it basically has two neural network, a network that generates, a network that discriminate. I think it might be a little beyond the scope of this talk, right? And what is good about that, right? It is on the generative side. It creates, right? It creates text. It creates images. It creates. It is not just an algorithm that is passive, right? This algorithm can generate stuff, right? And the example that you see here, this is in the Wikipedia page, right? There is a version of GAN. There are hundreds and hundreds of versions of GAN, right? People have gone on to use it for all sorts of things, right? And on the image generation side, there is something called Style GAN, right? That is heavily funded by NVIDIA. NVIDIA is a GPU company, right? And GPUs are such a big thing when it comes to deep learning algorithms or deep neural networks and so on. GAN is, or generative adversarial network, is a deep learning algorithm, right? And NVIDIA has always been, very active in designing algorithms, coming up with new neural networks, and so on, right? NVIDIA funded project is what the StyleGAN is, and StyleGAN went on to generate this picture, right? If you look at this picture, the speciality is, right, there's no person like this in the world. The machine just created it, right? It creates photorealistic pictures, right? And there is downside to this. The downside to this is, you could actually create pictures that are fake. You could create videos out of it. You could actually make. So this is about creating an entirely new picture. You could also go on to create videos of, let us say, a celebrity or so. You could use a celebrity as the template, and then you can create a whole video out of it, right? So it's not just about pictures. You could end up generating videos and so on, right? And at the initial stages of the first version of StyleGAN 1 is what it's called, right? We could make out every picture. There were small deficiencies, right? So you could actually figure out, hey, there is a small blob here, right? And it's a fake image, right? You could figure that out, right? But the next generation of those algorithm became so phenomenally good that, this is what happened. So I'm sure many of you have heard of this word called deepfake, right? So deepfake is about generating fake voice, generating fake videos, and so on, right? It had gone to such a limit that it was literally not possible for humans to identify if an image or a video is fake, right? Is it generated by AI, or is it a genuine video, right? And video or voice, right? And this is the portal called Kaggle, right now owned by Google, right? It's a portal where data science professionals compete, right? So there are challenges that are put out regularly, right? And people come and compete, right? And one of the challenges with a prize amount of $1 million was put out there, And the purpose was to come up with an algorithm that actually can, that actually can distinguish a fake video versus a actual video, right? So a genuine video versus a fake video, right? So that's where the generative AI has gone, right? So machines can generate fake videos, machine can generate fake voice, right? And it could imitate people and so on. And let me just take a quick YouTube video. So there is an actor here, right? And he just makes the gestures, and the same the picture of Putin is or small clips of Putin is what the machine has ingested or learned from, right? And it's able to apply, it is able to transfer all of Putin's characteristics onto a video, right? And so as in like the AI is able to mimic the style of Putin, right? But only thing is the actions are from another actor, right? So in this particular case, there is another person who is doing certain gestures, right? The gestures are all transferred, and Putin's image is overlaid on top of it, right? So this looks funny, but it is phenomenally dangerous. Think of people being tarnished.
Putin is a very interesting example. He never.
And it's not just with faces and videos. It's not just with faces and videos. It is also with. It's also with audio, right? And that's scary. And now, so moving on, so algorithms that have been able to create not just designs, right? It is able to create images. See, the style GAN thing that I was talking about, right? Or GAN that I was talking about is what this is, and it has gone to the next level, right? You just have to specify a text like this: a small yellow bird with black crown and a short round pointed beak. Right? You put out a sentence like this, right? And the machine actually generates a picture like this, which is photorealistic, right? Or 12-year-old white-skinned girl child with dark brown eyes and brown hair, right? And it generates a picture like this. You just have to specify the text, right? And the machine just generates it. And it's not just random pictures, right? You can actually describe what you want, right? And it creates that, right? So it can be used for good purpose, and it can be used for bad purpose as well. On the art side, right, the same generative adversarial network have been used for something else, right? So you could take a picture like this, right? And then if Van Gogh, so this is actually Van Gogh's Starry Night, right? A very, very famous and expensive artwork by Van Gogh. Right now, in Van Gogh's perspective, if Van Gogh were to paint this cat picture, how would it look, right? And that's what you see here, right? Somewhere close to what Van Gogh could have done. So that those abstractness that is a signature style of Van Gogh is actually applied, right, onto a picture like this, right? And let me quickly show you how effective that is. See the Starry Night applied on a animation video. See that whole abstract style of Van Gogh is applied, right? Same way, right? If some of these people actually went on to paint a location or so, or so this is how it would have looked, right? Different styles of different artists being applied, right? Isn't Star Wars, right? All of these different movies where the styles are applied, right? And now it's other application, right? Some of what we work, right, is you provide a person's image, and then let's say you have a celebrity picture there or a model's picture there who has appropriate styles applied on her, right? And it is, let us say, for some of these cosmetic companies, right, where they want you to try out applications or try out virtually, right, their products, for example, a lipstick of a particular shade, right? And then what they would give you is, say, given that the model would look like this with this particular shade head, you would really want to see how it would look for you, right? And that style is transferred, right? Whatever is the makeup that is there in this model is transferred to your picture, right? So this is your, if this is your input picture, right, and this is the model's picture, right, that the cosmetic company would provide in their app, right, and it would actually virtually show you how you will look like when you apply that without actually physically applying it, right? So, and then you could actually go on to purchase the product if required, right? So these kind of things are becoming a very commonplace thing nowadays. And there are things that is really not going well in this COVID scenario, right? People wearing masks or there's sometimes crimes increasing, and because the people have worn masks, you're not able to figure out who it is, right? But these algorithms, these generative algorithms, have been put to use to, complete pictures, right? It could be a picture that is degraded or it has missing elements in that in the picture, right? The machine can actually fill that, right, like an artist would do, right? Someone with a fantastic, phenomenally good Photoshop expertise, right, could do the same thing is done by the machine, right? And this is suddenly very, very relevant in a COVID kind of scenario where people are wearing masks and then you have to track criminals and so on. This is a very, very handy tool, right? And again, GAN is one of those algorithms that is used, right? And some of the deep learning algorithms. So think of a scenario where underwater in a smudgy area, a diver would go and inspect if a dam, for example, has a small crack or so. So because it's so smudgy, right, you really don't know what is behind it. You only see faint image, but the human knowledge actually helps the person, guess with fair accuracy that there is actually a crack there, right? And that's what machines are able to do right now, right? So if there is faint pictures, right, machines are able to enhance that. There is this concept of super resolution that has been there for a couple of decades now, but the efficiency with which it does has grown phenomenally big, right? It's getting better, right? It's become realistic, right? And that's what it is, right? So people are using it for robots in murky water, smoky areas where, like a forest fire or so, you have faint images of people, animals there. Can the robots actually identify while it's exploring? And so on. I will skip all of this. I think we're running short of time. Now, so these all look trivial, right? But think of AI that evolves strategies, right? And that has been proven by companies like Google, right? Here we are talking about reinforcement learning and other algorithms, right, which actually come up with phenomenal strategies that has become superhuman capabilities of the machine, right? So it is is gone beyond the abilities of human, right? So in the screen that you see is a game called Go, right? And Go has number of moves which they say is equal to the number of atoms in the universe, not on Earth, number of atoms on in the whole of the universe, right? It is that complicated is what this game is saying. So several times, several folds more complicated than chess, right? And few years back, 2016, right? Google had acquired this company called DeepMind, and in 2016, DeepMind came up with an engine that beat the world's best Go player, right? And the engine that they built was called AlphaGo, right? And AlphaGo went on to play with multiple players and still won. After a point in time, they let AlphaGo play with itself, right, to come up with fantastic strategies, right? Things that people have never ever imagined, right? The engine was doing that, right? And so a year later, right, another company, the creator of the founder of Tesla, Elon Musk, also runs a company called OpenAI, right? And they are into AI research, right? They went on to create an engine that would compete with humans in the game of Dota, right? Dota is considered more complicated than Go, right? And it is a lot about strategy. Here it is about, protecting territories, acquiring territories, and so on, right? And the machines could do phenomenally well, right? It would repeatedly, right, consecutively beat humans, right? And right now it's in a stage where there are times when humans have beat the AI engine. There are times when AI engine has beaten humans, but a scenario like this where it flips and flops, right, changes, and it is AI always later, right? So that's always happened in the past, right? So right now we are in a situation where there are times when AI wins, there are times when human teams win, right? And now, what is the implication of something like this? The implication of something like this is, think of wars being fought now, right? All the governments, all the developed nations governments and large countries which have large military have always wanted to have minimal people on the field. They don't want army walking with guns in the field, right? They all are moving towards robots. The US, for example, is heavily on drones, isn't it? Large drones that carry large payload of weaponaries, right? And usually there is a person remotely controlling this. And think of it, instead of that person, right, AI engine is to take over. These are all things that are really happening right now, right? And can be scary and dangerous. It can be really, really scary, right? And so in terms of war, in terms of acquiring territories and all of it, which looks like a game-like task, can have far-reaching implication when it comes to war and so on, right? And so before I wrap up, right, let me give you a quick. So let me also open up one small blog by there's a blog by this person called Andrzej Karpathy, who right now works in OpenAI, right? And what has he gone on to do? He went on to experiment with several of these algorithms that can learn from certain content. For example, he provided the machine learning engine, the deep learning engine, 1 MB of all the articles by Paul Graham, right? Paul Graham, he's very famous in the startup ecosystem, right? And so he has his talks are very inspiring, right? So Andrzej Karpathy went on to feed 1 MB of text, right, which is like 5 years of essays by Paul Graham, right? And it had about 1 million characters, right? And the AI was able to generate text that maybe didn't mean at that time, 2015, right? It didn't mean, you know, phenomenally great. It was not meaningful enough, but it could generate fully formed sentences which were fairly grammatically accurate. Right? He went on to feed Shakespeare's work, and this thing that you see here was actually generated by an algorithm, right? And it looks as if it's very, very artistic, very much Shakespeare style, right? And it didn't stop with that. He tried with Wikipedia, tried with news, etc. He tried with research articles. He went on to also feed Linux code, right? And the machine created a code. Only thing is that it was syntax error free. Only thing is it didn't serve any purpose, right? But then the code that was generated didn't have syntax errors, right? And so that's where it is. From there, what has happened, right? There is a bunch of things that has happened. So, for example, the AI engines have been able to write code for web front ends, right, or mobile apps. So you can see here, there is a small picture that is provided as input. So let me just quickly show you this. It's an algorithm called mixed code. If you see, the person is actually showing that it is an image by dragging his mouse. It's just an image, right? In few minutes, you will see that given this image as an input, it generates code, right? Working code, right? So you can see that it generated that, right? And they are clickable piece of code, right? And that's where the world is moving. And this is 2016, by the way, right? And this is with another screenshot of a web page, and the machine has generated all of this, right? So, and when I talk to people about this, okay, now it has written code, but design is not an easy thing, right? And that's what a year later somebody went on to create. So what you see here is someone drawing on a board a design of a web page, very crude one, just boxes and so on, right? And on the fly, the AI engine develops a web front end or web page equivalent of it. So this is the crude design, and then there is a web page that is generated on the fly, right? And things are changing, right? Our own company has been working on, software that can write unit testing codes, right, and so on, right? Small pieces of code, right? And there's a software that could actually write unit testing code, and it is a tedious process when it comes to development teams, right? And these are all things that are happening. So, and it doesn't stop with that, right? The last part I would want to talk about is something called AutoML, right, where machine generates machine learning code, right? So automated machine learning is what it is, and Google went on to create phenomenally amazing algorithms that generate amazing neural networks, right? And they're called NASNet, right? If some of you are interested, please go and explore NASNet, right? And things have changed way. It is since the papers around NASNet was released, things have progressed way farther, right? And so machines are able to create algorithms itself. Machines are able to write great articles, from Andrew J. Karpathy's article that we saw in 2015 to now, right? There are fantastic algorithms like the BERT and GPT-2 and all of it, which generates natural language content, right? Given that the machine can generate natural language content that are meaningful, given that the machines can generate video, given that machines can strategize and so on, right? If you put all of those ingredients, right, that is phenomenally good for, take for example, a production company. You can make a full-fledged animation video out of it, right? You just have to tell what it has to do, right? And the machine is going to generate stories for you. It's going to generate videos for you and so on, right? At Curvelogics, we are working with one of those Irish companies which is heavily into production, right? And we are right now building a product that actually can do a rudimentary version of it, where you the machine has some basic scripts there, templates based. It is based on certain templates. There are videos that are created, right pictures are pulled in, right positions within the frames are set, all of that, right? All of that done by AI engine, right? So this is where it is going. I think generative AI is going to make big impact. It is going to save us a lot of time, right? And it's going to make lives of engineers easy. It's going to make lives of artists easy, right? And we are all going to be using very, very smart applications to do better things that are way better than the things that would take us a year. Maybe we will finish it in a week, right? And that's what is going to happen because of generative algorithms and generative AI algorithms, right? So I will stop the talk here, and then I think we will have question and answers. And can you hear me?
Yes, sir. Yes, so we'll move on to the questions from the users, from viewers. The first question that we have is there any drawback using generative design?
These are all in early stage. There are, like humans can make mistakes, there are definitely deficiencies, and things can go bad as well, right? But then right now it is with a human supervision, right? You are given the choice of multiple designs, right? And there is an element of humans making the final choice. But what people are also working is they're building AI engines that will do the right selection as well, right? To evaluate all those metrics that are to do with performance, right? And people are working towards that, right? But there are times things are not perfectly well, right? But then these are all things that are evolving. This technology is evolving. It's going to get better and better. Already in a lot of these areas, it has gone to superhuman capabilities, right? You know that today's AI is nowhere close to a human child even, right? But in very narrow areas, very, very extreme, for example, computer vision, right? It has been able to do phenomenally well, way better than humans, right? So that's what it is, right? So there are deficiencies. It is right now there's a human element to pick the final, design that is there, right? And final decision is of a human. So there are some downsides like that.
Okay, sir. For the next question, instead of just using generative algorithm to produce code for web design, is there a possibility of actually feeding in any kind of algorithm, any kind of code, and generating error-free executable code for that? Is there any possibility for that, or any studies related to that?
Yeah, it is happening, right? So there are algorithms that can write SQL queries from normal text. You could just talk, and the machines will translate that into SQL queries and do the query from databases, right? You have things like that. You have so like I was saying, our own company writes test codes, right? And so that is all way beyond just web apps and mobile apps and so on, right? So the web app and the mobile app front end was just a proof of concept in 2015, right? Things have changed so much, right? So machines are able to write codes that are error-free, but it's still in an early stage, right? But if it is effectively able to do that, you know that in few years it would just get there'll be a lot of research that gets into it, and it gets better and better and better, right? In some time, some of the superhuman capabilities that we are talking about in certain other areas, that is going to come into programming as well. But the disruption in the society would be more and more people able to generate codes, right? Why should coding be such a difficult thing, right? End of the day, we need to tell the objective, and the machine, if it can generate software or automation associated with it, that is the ultimate objective, and all many companies are working towards that, right? The reach for creating, but there should not be dependency on small segment of people, right? And that's what all the companies are working towards. Coding is going to become simpler, but that said, we are all of you are engineers, right? It doesn't mean that you lose your jobs. You're going to be using uh, some of these tools to do even phenomenally bigger tasks. Right? We are talking about right now. We are talking about things that are meant to automate, like a website or a ERP system or so on. Right? We will be working in some time on more complicated things like autonomous cars, right? Autonomous drones, right? Interplanetary voyages, right? And so on, right? And at that time, the complexity of task that is supposed to be done is going to be far more, and it becomes mandatory for using fast tools like this, right? So you're going to be using these tools to create better things at a faster pace, right? So it is definitely not a risk for engineers. You're going to be using this tool, and going to be doing you're going to be generating outputs that are far superior to what you do today. And that's how I see it. Okay, and can we look at the other
Okay,
questions?
sir. Yeah, so the next question is, what new areas do you see generative networks find their way into?
It's extremely difficult to answer. There is
Yeah.
you name it, and generative. So the way to see it is AI algorithms are what are we talking about AI algorithms, right? We are talking about AI algorithms that do very similar to what humans can do, right? And that's why we call it artificial intelligence, right? Machines that can think and work and strategize like humans. That's what it is, right? So it's a direct competition with human intelligence, right? So people have tried to apply generative algorithms in all walks of life, right? From HR to automate, from paintings to HR to coding to all sorts of areas, right? So I think it's very difficult to even say which is that single segment where generative AI is applicable. And
Okay,
can
sir.
we,
And one more question. What are your thoughts on GPT-3, the
GPT-3,
generative pre-trained transformer?
yeah.
Yeah.
So GPT-3, like I was mentioning, so BERT and GPT-3 and all of them have are the big breakthroughs, right? So if you look at my own company here, Curvelogics was primarily focusing on computer vision, right? Because we could actually create practical solutions for our clients, right? We were shying off from NLP because NLP was very immature, right? But if you look at 2017 and 2018 and later, like 2018 when we had BERT being released, right, and that whole transformer revolution, right, uh, started getting accelerated faster, right? And GPT-3 is one of those with so many billions of parameters there, right? So billions of parameters is what makes GPT-3 very effective, and it is able to create content, right? Like it is able to analyze text phenomenally well, right? And with where it's sometimes difficult to distinguish what a human has done versus GPT-3. But if you look at some of the senior management in OpenAI, they've said that GPT-3 is overly hyped, right? It is definitely big breakthrough, but then sometimes we talk too much about it. But GPT-3 is one of those next stepping stones to, um, you know, uh, NLP, NLG kind of thing, right? Where machines, so we will not laugh at the Siris of the world or Google Assistants of the world or Alexas of the world, right? I'm sure many of you have conversed with it, and after a minute or so, you find that those AI engines are dumb, right? And with things like GPT-3, right, this is going to change. We are going to have more realistic conversations, right? We are going to have AI engine able to comprehend from a lot of what is on the web, right, from documents and so on, right. So that's what I think about GPT-3. It's a great stepping stone to reaching closer to human-like conversations, is what I think.
Okay, thank you, sir. I think due to the time constraint, we have to stop here. And thank you so much for spending your time with us today. And it was a very informative session. We were honored to have you with us, sir.
Thank you, Anne. Thank you all. It was a great honor. Thank you.
Yes, thank you to all our viewers as well. We hope to see you all in the next month's webinar series too. Yes, thank you, sir.
Thank you. Bye-bye.